Send a message to a language model and it responds. Send the exact same message again and it responds identically. It has no memory of the first call. The model is a pure function. Text in, text out. And here's the uncomfortable truth that follows. Nothing about the model itself is agentic. The thing that makes it an agent is the code around it. That code is the harness, the engineering term for the scaffolding that drives and monitors a system. The loop, the tool dispatch, the context manager, the stop conditions, the permissions layer. A well-built harness is invisible when things go right. It is the entire problem when things go wrong. Start from the deepest fact. The model is stateless. Every invocation starts from whatever you put in the context window, nothing more. So if you want the model to remember what happened 2 steps ago, the harness has to put that history into the prompt. If you want it to use a tool result, the harness has to run the tool and append the result. That is why the harness exists. And the core loop is tiny. While not done, call the model. If it's a tool call, dispatch the tool and append the result to context. Otherwise, return the text. That's not pseudocode for the hard part. That is the entire structural idea. Every framework, LangGraph, MAF, ADK is just this loop with opinions about state and error handling. But a real harness needs 6 components wrapped around that loop, and most of your engineering budget goes into them. Let's walk all 6. 1. The loop itself. Think, act, observe. The model thinks, generates a response. The harness acts, runs the tool. The model observes, the result is appended for the next call. 1. Iteration, 3 steps. 2. Tool dispatch with schema validation. The model requests a tool by name with JSON arguments, and the harness checks those arguments against the declared schema before calling anything. And this is the key design choice. Validation lives in the harness before dispatch. So bad call returns a clean, formatted error the model can read and retry from instead of a raw Python traceback that kills the run. 3. Context management, because context windows are finite. A naive harness that appends every observation forever eventually overflows. So you manage what stays. A sliding window keeps the last n messages. Compaction summarizes old history into a shorter form. Retrieval stores old observations externally and pulls back only the relevant chunks. Always a trade between memory and fidelity. 4. Permissions and sandboxing. The last line of defense before side effects. Tools write files, call APIs, send emails. And here's why it lives here. The model cannot enforce its own permissions. It can only request actions. The harness is the only component running with real system credentials. If an adversarial document tells the model to call a destructive tool, the harness either stops it or it happens. 5. Stop conditions and runaway guards. A loop with no stop condition runs forever, burning tokens and producing nothing. Max steps, a hard cap. Max tokens, a budget. Repetition detection, if the model calls the same tool with the same arguments twice, it's stuck. And a wall clock timeout. A good harness trips the cheapest guard first. Token counting is free before an expensive final model call. 6. Verification. Not every loop should end at the model's first run. For tasks where correctness matters, the harness runs a check after the model declares it's finished. Execute the code and confirm it doesn't throw. Parse the output against a schema. It's the evaluator optimizer pattern applied inside the harness, and it catches a real fraction of hallucinated final answers. Walk the code and you can see all 6 in one place. A tool registry, a validate and call function, a window trim, a permissions check, repetition detection, and a verification step. All wrapped around that little while loop. And the payoff is conceptual. LangGraph makes the context an explicit typed state and the loop a graph. EMAF adds a message bus. ADK adds a Google Cloud deployment. But strip every framework back and you find this same while loop, this same dispatch table, these same stop conditions. Understand the harness first, and framework choices become syntax questions, not conceptual ones. Because the model was never the agent. The harness is